This is the second video I'm doing on proofs for IB. This section of the book deals with proof by equivalence. Okay, so the first one was proof by, now I don't remember, deduction? Basically, that one was saying that the proof by deduction was telling us that we would have A implies B and kind of work our whole way down. This implies this, which implies this, and we'd make our proof go from this particular point, and then maybe B implies C and C implies D, and then you could prove, therefore, that A implies D or whatever. And this one, proof by equivalence, what we are needing to do is we're going to show that A, if and only if B, the whole way down. Okay, so each statement we write would go, not only would A imply B, but also B would imply A. So that's what we're looking at here. And then the first example that they do in the book is they ask us to deduce the solutions of this by writing a series of equivalent statements. So as we begin, we know that this previous statement, well, maybe I should write it, x plus 1 cubed is equal to x cubed plus 1 was our initial statement. And this would be equivalent to, well, now we can expand this out. So we've learned how to do that. So this is x cubed plus 3x squared plus x plus 1 is equal to x cubed plus 1. And this statement here is equivalent. That sign got in the wrong spot because it just did. Okay, so therefore I have expanded this. All I've done is used the binomial expansion to, oh, I am so wrong. Good thing I looked back at that. Okay, so it's 1, 3, 3, 1 is that row from Pascal's triangle. And this would be equivalent. Now notice I can subtract x cubed from both sides, and I can subtract 1 from both sides. So this would be equivalent to 3x squared plus 3x is equal to 0. Now, I can then therefore say, well, it would be equivalent to factor out this 3x times x plus 1. This statement is equivalent to that one. I can go from here. I can go either direction to get to the next one. And then what I can say is that x, well, 3x would need to equal 0, or x plus 1 would need to equal 0. Okay, this is exactly equivalent to that, and also I could work my way backwards. Therefore, and that would be equivalent to saying that x is equal to 0, or x is equal to negative 1. Okay, so now we have found the two solutions to this by writing a set of equivalent statements the whole way down. The next thing that we wanted to prove, I'll make this all the same video. The next thing is they say find the smallest positive integer a for which this has real solutions. So I think our textbook may do it one way, and I am inclined to do it slightly differently. Do you know what? We'll put this in a second video.